Hey everybody, today we're going to talk about piecewise defined functions, and I've got an example here for you. Notice that we have the function f of x equals x squared minus 2 and also f of x equals x plus 3. Now the thing about this is the x squared minus 2, we know that's a parabola, okay? But it's only going to look like a parabola on the left side of x is less than negative 1. And then the graph is going to change its look. It's going to become the line x plus 3 when x hits the negative 1 and finds values greater than negative 1. Okay, so we know it's going to look something like this. Let's just get an idea. We know x squared minus 2, like we said, that's a parabola because we have x squared, and it's down 2 units. Okay, so it looks something like this. Okay, just a little sketch. We also have the graph x plus 3. Now we know that that's a line that has a y-intercept of 3, and it has a slope of 1 because it's 1x. So it's going to look something like this. But again, the two graphs are going to change when x is at negative 1. So somewhere around in this area at negative 1, this is what the graph's going to look like. Part of this, on the left side of negative 1, it looks like the parabola. On the right side of negative 1, it looks like the line. Okay, so first of all, let's go ahead and do some evaluations. If they say evaluate the f of negative 3, what does that mean? You have to decide which equation you're going to use. So if x is negative 3, you ask yourself, which equation do I use? Is negative 3 less than negative 1? Yes. So we're going to put negative 3 in place of this x right here. So we're going to have negative 3 quantity squared minus 2. Well, of course, negative 3 quantity squared is 9. 9 minus 2 would be 7. So when x is negative 3, the y value is going to be at 7. Okay, let's look at f of negative 1. Well, is negative 1 less than negative 1? No, it's equal to it. So we look, is negative 1 greater or equal to negative 1? Yes, it's equal. So we're going to put the negative 1 in place of the x in the second equation. So we're going to have negative 1 plus 3. That's going to give us a positive 2. So when x is negative 1 on this piecewise graph, the y value is going to be at 2. All right, let's try f of 0. Is 0 less than negative 1? No. Is 0 greater or equal to negative 1? Yeah, 0 is greater than negative 1. So again, we're going to use the second equation. So we're going to put 0 in place of this x. 0 plus 3, which gives us 3. So 0, 3 will be an ordered pair that belongs on this piecewise graph. All right, let's look at positive 1. Is positive 1 less than negative 1? No. Is 1 greater or equal to negative 1? Well, yeah. So again, we're going to use the second equation. We're going to put 1 in place of this x. So we have 1 plus 3, which turns out to be 4. So those are a few ordered pairs that belong on this piecewise defined function. All right. Now, let's say that they ask us to graph this, exactly what it looks like. Okay, this is what I would suggest that we do. Okay, I'm going to write the problem again down here. We have f of x equals, and again, there's two separate equations. The first one is x squared minus 2, but you use this picture when x is less than negative 1. And then we have the other equation, x plus 3, but you only use this equation when x is greater or equal to negative 1. Okay, so what I suggest that you do for each equation, make its own table. Okay, so we're going to have y equals x squared minus 2. That's one equation. The other one was y equals x plus 3. And what I always do, I make an XY table for this, because remember, f of x is just a fancy way of saying y, but it's written in function notation. All right, so we're going to make a table for each one. And what I always do is where the graph changes at -1, I make sure I put that point on the graph, okay, and on my table. So I'm going to put -1 on the first table and -1 also on the second table. All right, now I also need to pick numbers less than -1. So that would be numbers like maybe -2, -3. I could keep going. Now remember, x is less than -1. So the graph begins there, but it doesn't actually have that point included. It does not have an equal sign. So what I do on my table to remind myself that -1 is not included in this part of the graph, I circle this. Okay, to remind me on my graph, it's going to look like an open circle. Okay, so let's put in -1 into our equation. Of course, -1, if you square it, becomes +1, and 1 minus 2 is -1. If we put -2 in place of x, if you take -2 and square it, it becomes a +4, and then 4 minus 2, of course, is 2. And then we'll try another point. -3 being squared is 9. 9 minus 2 would be 7. So we know that this is going to look like a parabola on the left side of -1. Now we can go ahead and graph that part, okay, the x squared minus 2. So at -1, -1, that's going to be an open circle. So we're going to go to our graph, we go left 1 and down 1, and we put an open circle because it's not included. At -2, we have +2. And then at -3, it goes all the way up to 7. Well, that only goes to 6, so we can estimate that's probably about 7 right there. So it's going to look like a parabola on this side. So we're just going to connect those points, making that U-shaped graph. And remember, we could keep going to the left, so that's why we put an arrow on the end there. Okay, now let's figure out what happens on the other side. We know this looks like a line, okay? And we're going to use this equation when x is greater or equal to -1. So we already have the -1. So let's pick some numbers that are greater than -1, such as 0, 1, 2. Okay, we'll plug that into our equation. -1 plus 3 is +2. 0 plus 3 is 3. 1 plus 3 makes 4. And 2 plus 3 makes 5. So here are some ordered pairs for this graph. Now again, notice that -1 is included with this graph, so we'd have a closed circle here. So at -1, 2. So at -1, +2, that would be a closed circle. 0, 3. 1, 4. 2, 5. Notice it's a line that has a slope of 1. So it's going up 1, right 1, up 1, right 1. And then we're just going to connect that and draw an arrow because it could keep going forever to the right. So that's how you graph a piecewise defined function.